like to wish you, everyone, a Happy New Year and with good health and in good spirit as well. I was glad to be part again to another webinar, so thanks for inviting me. This presentation is specific to thermal insulation, which is a key component in the design of wall, floor, and ceiling assemblies, because it ensures to provide comfort to the occupants. It reduces the heat loss, and it lowers the risk of condensation. And speaking about heat loss, this reminds me a personal project a couple of years ago when my partner and I did major renovation to our house. We demolished a lot of the walls, and we discovered that there was no insulation. All the cavities were empty. There was only a wood fiber sheeting installed on the exterior side. So I was kind of surprised, but not surprised at the same time, because this partly explained why we were freezing in the house. But it surprised me because it was the first time I've seen such a thing. I've been working for a consulting firm prior in RC, and I did different building investigations, and I've never seen this before. My house was built in 1952. So it's not that old compared to the century-old buildings and houses in Europe, where I had the opportunity to visit some of them during renovation, and I noticed that there was insulation. Okay, the insulation was animal poo type of insulation, but at least there was some insulation. Anyway, at the end of our renovation, we were glad to notice that the heating bill actually dropped down, although we did double the size of the house. Hence, the importance of thermal insulation, as well as having an air barrier system installed properly. So let's start without further delay the presentation, which is divided into 5 segments. I thought to first explain the basic knowledge on heat transfer, what are the modes of transfer, and how to control the heat transfer. And as well, I'm going to explain the National Building Code Part 9 requirements for thermal insulation. Then I will show how to search for CCMC evaluation of thermal insulation using the CCMC online registry. And under the 4th segment, I will briefly go over the fire protection requirements related to insulation under Part 9 of the National Building Code. And at the end, last segment, I will explain the energy efficiency requirements, again related to thermal insulation. The overall presentation is limited to Part 9, so housing and small buildings of the National Building Code. So the first segment, basic knowledge, this is just to go quickly over the mode of its transfer and how to reduce the heat loss. During the warm season, the heating season, the heating system provides warm air through the building, through the different rooms. So the heat flows through the different rooms and warm up the rooms. However, the heat has a natural tendency to travel through the exterior ceilings, walls, and foundation, and as well the floors. But in order to understand what to do to reduce that heat loss, it's good to understand by which mechanisms the heat flows through the wall assembly, in and out the wall assemblies. So let's have a look at how it works. This slide illustrates the heat transfer through the assembly. The heat flows from a high temperature area to a lower temperature area by 3 mechanisms: conduction, convection, and radiation. This is simply illustrated by a hot pot here. So let me explain the conduction. Conduction means that the heat is transferred through the direct contact between adjacent bodies. So you need to have two bodies into contact. It could be solid, it could be air, it could be gas. And in this illustration, it's the hot handle in contact with the hand of a person. So the heat from the hot handle is transferring to the hand of the person. Same thing when you're touching a cold floor with your feet. The warmth of your body, the heat of your body is transferring to the cold tiles. And this phenomena is occurring in the building assembly, like the wall here, where you have the drywall on the interior side touching the stud or touching the insulation. They are in direct contact, so they transfer the heat. And if the insulation is touching the exterior sheeting, same thing. There is transfer of conduction, this transfer of heat through conduction. And this phenomena is occurring during the warm season, but in the different direction. With respect to convection, convection means that heat is transferred due to the movement of a fluid. When a fluid starts to warm up, its density becomes less dense, so it rises to a level where its heat is given up to a colder liquid, and it's creating a convection loop, like what is shown here in the hot pot. You have the liquid here, which is warm up at the bottom, and as it rises up, it is giving up its heat to the section of the liquid which is colder, and this is creating convection loop. This is happening in the wall assembly along the exterior wall and within cavities where there is airspace, if there is no insulation or if there is an airspace. The third mechanism is radiation. Radiation is occurring at an atomic level. It's occurring through electromagnetic waves, and more specifically, infrared radiation. So the source here is the fire that heat the pot through radiation. And radiation can occur, heat loss by radiation can occur with a building through windows. But there is a fourth mechanism of transfer of heat, and this is by air mass transport, where the driving force is not the temperature differential, but it's the pressure differential. And this is occurring in the wall when there is holes, so the air would flow by mass transport. If there is holes within the walls where you have penetration, like electrical box, perimeter of pipes, gaps between the window frame and the roof opening. And this can occur in the opposite direction during the warm season. But how to control that heat loss? Well, with respect to conduction, convection, and radiation, the first three mechanisms of heat transfer, you need to have materials with good thermal resistance in your assemblies. To control the heat transfer by air leakage, you need to have a good air barrier system installed. But this presentation will be limited to thermal resistance. Which brings me to the second segment, which is related to the National Building Code Part 9 requirements for thermal insulation. I will explain all the insulation standards that are referenced in the code as a code acceptable solution. I will explain some of the requirements from the labeling section within those standards, and explain the general requirements within Part 9 for installation of insulation. So the National Building Code Part 9, subsection 925.1 and 925.2 requires that walls, ceiling, and floors must include an acceptable insolution material, which are listed here under sentence 925.221. So they are all listed here. These product standards have been developed by either ULC, CGSB, and ASTM. And I'm sure you are aware of these, like, for example, the polystyrene standard, mineral fiber, cellulose, spray foam, and so on. The code says as well that you must install sufficient thermal insulation to prevent condensation, to ensure thermal comfort, and enough insulation to comply with the energy efficiency requirements, which will be part of the last segment of this presentation. Before I go over the different USC standards, I'd like to explain how the standards are identified. How does it work? This is an example for spray foam medium density. USC represent the first acronym. USC is to explain which organization has developed the standard, so the issuing agency. Then it is followed by the document number, which is specific to the product standard. And at the end, you have the date of publication, modification, and or reaffirmation. If this identification number is preceded by the acronym CAN, this means the product, the standard has been developed in accordance with the Canadian regulation for National Standard of Canada. So what I'm going to do in the next following slides is I'm going to go over the different USC standards that are referenced in the code and explain a few things about the testing, the labeling, and properties, and if there is any installation requirements related to those standards. I've been to Home Depot lately, and I took a few pictures of some products, so I can show you a few pictures, and especially for the labeling. So I will start with USC S701.1, which is related to polystyrene, EPS and XPS. EPS stands for expanded polystyrene, and XPS stands for extruded polystyrene. Both boards are manufactured from beads of styrene that are expanding. The EPS is the way it is manufactured is that they use pre-expanded beads that are poured into a huge mold. It could be 10 feet by 10 feet by 8 feet. And then the beads are expanded to create a huge block of EPS, which is then sliced with hot wires to create those boards here. XPS is not molded, but it's extruded with to a specific thickness. The difference between EPS and XPS visually, you can look at the cross section of the boards, and for EPS, you will see that the cell size are much bigger than the XPS. So the standard S701.1, the material standard, specify a couple of properties to be tested, such as thermal insulation, dimensional stability, flexural strength, water absorption, compressive strength. And some of these standards include surface burning characteristic in case there is fire hazard, so they want to know how the product performs under fire. This standard classify EPS and XPS under 4 types, and depending on the criteria to meet, if the type is, let's say that you are looking at a type 4 has to meet criteria which are more stringent than type 1. I want to open a parenthesis here in terms of thermal resistance because, or maybe I should go back. Let me go back to this slide. I don't know if it's clear enough for you if you can see the details of this table. Table 1, which is part of the standards, says that thermal resistance must be tested and long-term thermal resistance must be tested. Let me explain the difference. Some insulation, especially the plastic insulation, some of them, the thermal resistance decrease over time. So it's important to assign the proper test depending on the product. Let me explain. The first part of this slide on the top here, it is related to insulation for which the thermal resistance does not decrease over time. This is mostly the case for EPS, mineral fiber, cellulose, wood fiber board. There's no blowing agent that are captive within the insulation. So it's a standard type of test that must be done to establish the thermal resistance. So we call it RSI value or R value of the product. But when the insulation retain a blowing agent for more than 180 days, it is important to estimate the long-term thermal resistance of that product. So we are no longer talking about R value, but we're talking about LTTR because the thermal resistance will decrease over time, and we want to estimate what will be that value at 5 years, because then it's going to reach a plateau, it's going to stabilize. This is valid for XPS, spray foam, which are medium density, so the 2-pound foam, and polyazo board. So the test is a little bit different. It's USC S770 that is performed in order to determine the LTTR. So I'm back to the S701.1 standard for EPS, and I just want to show a few key things with respect to labeling. Most of the insulation standard requires for labeling that, of course, the product name must be installed, the manufacturing name must be installed, the location of the facility where the product has been installed, is it in Canada, US, in China. Some standard requires that a caution with respect to fire hazard will be stated on the label and so on. But I'm going to limit my comments on a few things, such as the thermal resistance value and the identification of the standard. I'm showing here on the left side a photo of EPS board where the label has been printed on the board. And you can see the USC S701 type 2, which is identified properly, and the thermal resistance. Since we're talking about an EPS here, we are talking about thermal resistance in terms of RSI value, not long-term thermal resistance. And here the certification body who did the assessment of the product is stated. On the right side, there is another product where the label is printed over the board, but as well there is a sticker that specifies the RSI value per inch, which is good. For XPS, in terms of labeling, what is important is that they are showing the LTTR because it's XPS. So the LTTR must be shown for design values. Showing here the identification of the USC S701.1 and the type, which is good. And on the right side, this is another board where they are showing R7.5 per 1.5 inches, but because it's an XPS, they should have shown LTTR instead of R value. So this type of information may be misleading the user. But when you see the CCMC number as shown here on the right, you could log on to our registry and double check the LTTR that we are publishing for product. Next, insulation standard S702.1. This one is for mineral fiber insulation. Mineral fiber insulation is typically made from mineral fiber, glass fiber, or rock fiber, and it comes in the form of bats, rolls, boards, and as well loose fill. The insulation material, which is here the cover page, includes requirements for testing multiple properties again. So I won't go over all of these. There's always thermal resistance, of course. Water vapor permeance. In this case, we have fungi resistance, corrosiveness, smoldering resistance, and so on. The standard classify mineral fiber in multiple types. The preformed are identified as type 1, 2, 3, and it depends if there is a facer, no facer, if the facer is a vapor barrier, and loose fill is identified as type 5. There is no assignment for type for at this point. It comes with an installation standard, which is S702.2, and it includes a few requirements. For example, for the bats and rolls, they must be installed with friction fit. There must be no gaps, no overlaps of the bats. The bats must fill the full cavity, depth, length, and width. And with respect to boards, the board thickness provided on site must meet the design thickness. With respect to loose fill comes in bags, which are they are packaged with specific requirement of density, compression, etc. And the standard requires that the product be labeled with an application chart. What I mean by that is information with respect to the thermal resistance, the minimum thickness, the minimum mass per area, the maximum coverage per bag, and the minimum bags per area. So this information must be part of the job site certificate that the installer should provide on site and install that in an area where it's going to be available. Usually it's close by the electrical panel. Here are some examples of the labeling for the bats. On the left side, I'm showing a bag here with the identification of the standard USCS 701.1. There's the CSMC number. You can go online with our registry again and check the information. On the right side, I've turned the bag so to see the rest of the information. They are showing the number of pieces, the size of the bats, the R value on top here, and here is the coverage per square foot. This is the label for loose fill, and again, they are showing the standard with the type, which is good information, and at the end, they have to show as well the application chart, which is required by the standard. If you don't see the standard identification on a product, then you may ask yourself, was it assessed? Was it evaluated by a certification body or another evaluation body? With respect to cellulose, the corresponding standard is S703. Cellulose is made of typically of recycled newspaper, and it is classified in two types. The type 1 showed on the left is for dry application, and it's applied with pneumatic equipment, or it can be poured in. So if it is installed in attic, the slope must be maximum 4.5 in 12. If it is installed in vertical application, or let's say a cathedral ceiling, then there is a need for a retaining membrane. It could be a net, as long as we see through, so the installers see how the cellulose is installed in place. On the right side, it's for type 2, means that the product is installed using a liquid. It could be water. The intent is to increase the cohesion between the fiber, so there's no need for a retaining membrane to be used. However, at the end of the application, you may see from the picture here that the cellulose is exceeding the depth of the studs. So the installer, once it's done, he will have to scrape the exceeding fiber using a squeegee or something like that. The cellulose material does not come with a separate installation material, but installation material. So there's no specific guidelines or a separate standard for the installation of cellulose. The material standard for the cellulose requires, like all the others, a couple of properties to be tested, from design intensity, corrosiveness, fungi resistance, moisture, vapor absorption, and so on, and some as well surface burning characteristic, and of course the thermal resistance. And with respect to labeling, I could not find a bag of cellulose, but I'm showing here on the right side, it's a copy of a technical data sheet from a manufacturer, and on the left side is an excerpt from a CCMC evaluation of that product, actually. What I want to show here is that the information of the coverage chart must be shown on the TDS and the label. And this is what we are publishing on our evaluation. So we are showing the R value, the minimum apply thickness, the minimum settle thickness, mass per unit area, and maximum net coverage per bag. Next one is S704. This one is for polyisocyanurate board. These boards are manufactured with isocyanate and resin. So they blend isocyanate and a resin. The resin contains different chemicals such as blowing agent, fire retardant, surfactant, and so on. And they come with a facer on both sides. They are classified in different types from type 1 to type 6. And this standard in the appendix C, they mentioned that type 1 is typically used for walls. Type 2, 3, 4, 5, and 6 is mostly for roofing applications. With respect to labeling, it's always the same idea. You should see the manufacturer name, product name, the location of where the product has been manufactured, which country of manufacture, and so on. But I'm just pointing out here that there is some issue with the label here because they are showing ULC. They should show the complete identification. The number should be there because otherwise we don't know to which standard they are referring to. The type and class is specified, which is good. On the right side, this is another case of a label, and they are showing R value and LTTR value. And this is what I want to highlight to you. Like I said earlier, for XPS, spray foam, medium density, and polyiso board, like this here, we need to use only the LTTR for design in Canada. So this labeling here may be misleading to the user. They may not know which one to use. But for product access in compliance with S704, it's the LTTR value that needs to be used. Medium density spray foam. Standard is S705.1. And as you know, these products are finished on site. So they have to bring over the site the isocyanate container and the resin container, which are mixed on site through a spray gun. So they are using mobile rig in a truck and install the foam with using the proper pressure and temperature. So this material standard referred to an installation standard, which is S705.2. The material standard requires multiple properties to be tested as well. And because we're talking about spray foam, the table of testing the physical requirements refer to LTTR and not RSI initial. So it is specifying long-term thermal resistance. With respect to the installation requirements, the standard includes requirements showing the responsibility of all the parties involved in the delivery of that insulation system. The manufacturer's responsibility, the contractor, and the installer responsibility. The certified installers has to do some testing on site. They have to do adhesion test, cohesion, and density. They have to fill out their daily work record. And if there is renovation, they must ensure the spraying area is isolated and ventilated. The time to occupancy must be respected. In most of the, for most of the evaluation, it is 25 hours. The maximum thickness to spray per pass is 50 millimeter, otherwise there might be a fire hazard. And they must provide a job site label, which in this case as well would be available close by the electrical panel. They must ensure that all permits have been approved. And because, again, this is a site applied product, there must be a site quality assurance program in place. And it is a third party who provide that site quality assurance program. This provider of quality assurance will certify the installer and will ensure there is site audits. Any authorities, even a homeowner, can require a site audit done by the third party providing the site quality assurance program. And this is a copy of a job site label template from the standard. And it has to be signed and filled out by the certified installer. So it provides information on the product name, licensed contractor, certified installer, and the address of the job site, and so on. With respect to labeling, there is information that are required for the label for component A and specific requirements for component B. On the right side, I just want to highlight that the standard has been properly identified. Here there's a SSNC number specified, the LTTR has been specified, there's no confusion between LTTR and R value here. And as well, I want to highlight to you that spray foam have a shelf life. So it's important to look at these dates because usually it is 6 months to 9 months, the shelf life of a spray applied polyethylene foam. And for wood fiber, the corresponding standard is S706. Wood fiber are made of wood fiber and they comes with usually a facer at least on one side. There is no installation standard for this one, but the material standard refer to multiple testing as well, like the other standards. And they classify the product in 2 types, but it's classified in subclasses and grades. It's a very complex classification for wood fiber board. And they have specific testing and criteria to meet depending on the type and class. In terms of labeling, I haven't found a fiberboard panel to show you a label on the actual board, but I'm showing here the technical data sheet for a wood fiber board, and they are showing the thermal resistance value here, which is correct. They are showing the standard identification with the type and class. The CCMC number is not stated. They show CCMC, they should have stated the number. So in doubt, you may contact CCMC and ask if a specific product has been evaluated by CCMC. And this is the last standard I wanted to show. It's 712.1 for light density spray applied foam. It's not yet in the code. It may be referenced in the next edition of the code. This standard refers to a material installation standard, and it includes multiple types of testing to be done as well. The only thing I wanted to highlight, because it's very similar to medium density foam, so I won't go through the whole aspect of this one. The thermal resistance here is not LTTR because it's a light density spray foam. There is no captive blowing agent. So it's correct to refer to thermal resistance and not LTTR. Now, with respect to the following requirements in the code, beside the list of all the standards, there is general requirements with respect to installation, and I'm referring to Article 925.2.3 of the building code. There is 8 sentences reference in that article. I'm going to focus only on the sentence 1, 2, and then 5. With respect to 1 and 2, this is related to the goal of reducing convective air movement in the cavity. So the baths, if it's bath tubes, then you need to make sure there is no pockets or gaps between the bath and the stud and the other parts adjacent to the insulation. Also, the cavity must be fully filled with the baths, and the bath should not be compressed because compression will affect the thermal resistance of the bath. And regarding sentence 5, this one is related to insulation around slab on ground, and it says that insulation around concrete slabs on ground shall be located so that heat from the building is not restricted from reaching the ground beneath the perimeter where exterior walls are not supported by footing extending below frost level. So what it means is that if your foundation are not below the frost level, make sure that you're not blocking the heat from the building reaching that area of the foundation. You want to keep that area warm, so you don't want it to freeze because it's not below the frost. If it does, then it's going to crack. So it's the same thing if you're renovating an old house and there is, let's say, foundation and footing, but you don't know the depth of the footing. Make sure you know first the depth of the footing to see if it is below the frost level prior you start to isolate, because isolation, as you know, will reduce the heat flow reaching that area. There is in the code as well specific requirements for loose fill insulation. These are under Article 925.2.4. And there is 6 sentences related to the installation of loose fill. I will just highlight number 2 and 6. Under 2, it says if you use loose fill insulation within open space, such as attic, for example, then the supporting slope shall not be more than 4.5 in 12 for mineral fiber or cellulose fiber, and not more than 2.5 in 12 for other type of insulation loose fill. Under 6, the code says this is in the area of the soffit and the attic where the loose fill insulation is installed on the ceiling. So the code says where soffit venting is used, measures shall be taken to prevent loose fill insulation from blocking the soffit vents. So you need a baffle like this showing in pink to avoid the loose fill moving out of its location and blocking the soffit. So you want to ensure that the airflow is continuous here. And also you want to make sure that any air movement will not disturb the insulation, because you want to maintain the thermal resistance property. The following article of the code refers to the installation of spray foam, but we went through this one. It specified that spray foam must be installed per S705.2. There's also a general requirements here related to insulation installed below grade under 925.2.2.3, and it says insulation in contact with the ground shall be inert to the action of soil and water and shall be such that its insulative properties are not significantly reduced by moisture. So you have to So designer, architects, and specifier must be careful when they choose a thermal insulation that needs to be installed below grade on the exterior side of foundation. So I'm now at the segment number 3 with respect to CCMC online registry. And I will just quickly show you how to search on using our online registry. We publish evaluation of standardized insulation, but as well innovative insulation. It is actually the raison d'être of CCMC to assess innovative insulation. So insulation not listed under the code, but when they are properly assessed and demonstrate that it complies with the code, they are equivalent to standardized insulation, then authority having jurisdiction may approve those evaluation. And you can search using our web page. The address is here. I can send it to John and he can send it to the group if you don't have it. This is showing the page of the CCMC registry of products. And you can search by using different keys such as insulation type, the product name, the standard number. I did a test here using S704 in the filter here, and I got a list of different insulation. And I'm using this example to show you how it looks. This is in PDF format, but we are changing our format into HTML. So you may see other listing with a different format. We are showing the design value, which includes LTTR, because this is a insulation foam called a polyiso board assessed per S704. So we are looking at LTTR value, water vapor permeance as design value, and we show the classification type 3, class 1. So under segment number 4, I will go over the few requirements related to fire protection under part 9 for thermal insulation. The National Building Code mentioned under the sentence 925.222 that the flame spread ratings requirement contained in the standard listed in sentence 1 that we looked at previously, shall not apply. Although most of these standards refer to flame spread rating or other type of surface burning characteristic. Although the code says shall not apply, but to meet a standard, and if the standard has a requirement of flame spread rating, it has to be tested. This section of the code also requires that foam insulation, if you install foam insulation, you must install a thermal. This is under 9.10.17.10. A thermal barrier can be a gypsum board or an interior finish. It is all explained under this article of the code. The code also says that if the exterior wall is a load-bearing walls, it has to have a fire resistance rating. And this is true if it's not a house. There's an exception for houses. But if it's not a house, then the fire resistance rating must be established per 9.10.8. And it's either it has already been determined and there is a table in the code that shows a list of different assemblies that have already been tested with the insulation within the assembly, but it's limited to standardized type of insulation. If someone is proposing an assembly with an innovative insulation within the assembly, then the code do not include in its table a fire resistance rating for an assembly with an innovative insulation. So there must be a test done in order to demonstrate what is the fire resistance rating of the assembly, including an innovative insulation. 925.113 includes requirements with respect to insulation in heating and ventilating ducts. It includes restrictions that apply to the use of foam plastic, but I won't go over them. You just have to look at 932, 933, and 936. And at the end, there is requirements for exposing building faces if it is determined that the exposing building face is must be of non-combustible construction, then the thermal insulation used in that assembly may need to be to meet the section 315 of the code, which relates to non-combustible construction. This is the last segment, and it relates to the energy efficiency with respect to thermal resistance. I will show an example, actually, how to calculate the thermal resistance of an assembly per the code, and where to look for the minimum requirements of the code. This section 936 of the code is concerned with the loss of energy due to heat transfer and air leakage. But this presentation is limited to heat transfer. So in order to reduce the loss of heat, the code intent is to ensure there is no excessive use of energy. And therefore, they have established requirements, minimum requirements to meet for the assembly. So all the assembly has to meet a minimum thermal resistance effective. Let me explain what I mean by RSI effective. And before I move to the other slide, I just want to highlight that the minimum requirement for above ground opaque assembly are stated under this table. This is when the building may have a HRV or no HRV. So depending if it is without HRV, then it's table A. With no HRV, it's table B. For below grade assembly, it's table 936-8. So when you look at a product or a material or a sheet, and you want to know the thermal resistance value, there is a standard test called STM C518 or STM C177, which is done in a laboratory to establish the thermal resistance of that product. User can look in different publications, such as the code. The code includes a table with a list of different thermal resistance properties for different materials. But when it comes to an assembly includes multiple components: insulation, interior finishes, exterior insulating sheeting, siding, and so on. It's not only one component that is tested, it's the full assembly that must be tested to determine the thermal resistance of the assembly. But the code language is RSI effective. Why effective? Because in a wall, especially made of stud, such as wood stud or steel stud, there is a repetition of stud, and stud are acting as a thermal bridge. So they are affecting the thermal resistance of the assembly. So you need to take into consideration in your calculation the effect of those studs, and the code explains how to do those calculations. If the assembly is not a simple traditional wood frame or steel stud cavity, then you need to test the full assembly in accordance with STM C1363. I'm showing here an assembly which is very simple. It's wood frame cavity 2x6 insulated. There is an interior gypsum board finish with a barrier. On the exterior side, there is an insulating sheeting and siding. So if you were thinking to calculate the thermal resistance of that assembly by just looking what's going on through the cavity, you would add the thermal resistance value of the different component from the outdoor air to the interior. So you would add the thermal resistance of the air film outside, the siding thermal resistance, the exterior gypsum board, sheeting. Here, actually, it's in pink, it's the insulating sheeting. You would add the glass fiber batt, thermal resistance, vapor barrier, and so on. And the total would be 376. But the code says this is not the proper way to calculate the thermal resistance of your assembly. It has to be calculated with the following manner. First of all, you have to determine the contribution, the negative contribution of the thermal bridge. So what is the area of the framing and what is the area of the cavity? These data are available in the table 936-4, and you have to establish what is the thermal resistance of the stud and what is the thermal resistance of this insulation within the cavity. When you have these data, again, they are available in the two tables here that I'm showing on the slide. When you have these data, you have to fill in the blank in this equation to calculate the RSI parallel. Percentage area framing over RSI of the frame, the wood, percentage area of the cavity, so the percentage that you get from this table over the thermal resistance of the insulation within the cavity. Once you have that number, you include it in your summary of all the different thermal resistance of the each component within the wall assembly, from outdoor to interior. And if you make the total of this, you will get 2.78. If I go back to the previous calculation, we had 3.76. So you notice, I guess, the reduction of the actual thermal performance of this wall when you consider NBC method of calculation. Once you have that value, you then compare this value with the code minimum requirement stated under table 936-6 or 28, depending on what type of assembly. This is an example, and I pull out the table 936-6A. This is for building without an HRV and a wall built above ground. If the wall is built above ground, then because we got 2.78 as an effective thermal resistance, the wall could be built in location only of zone 4. So if you want to build that design in Prince Albert, for example, where the heating degree day is 6,100, then this is limited to zone ZB, and under zone 7B, sorry, the minimum RSI effective of the wall must be 3.85. So we got from that assembly 278. So this assembly would not be compliant with the energy efficiency requirement for zone 7B. We need to modify that assembly, either add an insulation board on the exterior side of the assembly, change the current insulation within the cavity for insulation which has a higher thermal resistance in order to reach that minimum of 3.85. So at the end, I just want to summarize a few things that we discussed. The National Building Code Part 9 includes a list of applicable standardized insulation. There are two insulations that refer to installation insulation, which are USC S702 for mineral fiber insulation and S705.2 for spray-applied polyurethane foam. I brought your attention to the labeling because it's important to see if the product has been evaluated in compliance with the standard. So a label should include the identification of the standard, the proper thermal resistance value, and it's good if there is a CMC number on the product as well. There's other requirements for labeling, but I wanted to emphasize on these aspects. The products such as loose fill and spray foam insulation. Loose fill, I'm talking about mineral fiber and cellulose fiber, which are loose fill. There must be a job site certificate available on site. And in terms of other requirements from the code, there is general requirements for installation. We've been through this, and there's a few fire protection requirements as well that needs to be taken into consideration. I am going to highlight again the difference between RSI value and LTTR, which means long-term thermal resistance. Long-term thermal resistance is the proper thermal resistance value to use for design in Canada when a foam plastic includes a captive blowing agent, such as XPS, PIR, and medium density spray foam. Also, we looked at the effective thermal resistance of assemblies. So it's good to understand how these calculations are done. So it's not just a simple calculation of the thermal resistance through the cavity, but you have to consider the effect of the thermal bridges, such as the studs. And I just want to end by saying that innovative thermal insulation are available. Evaluation of innovative thermal insulation are available through CCMC website. We have evaluated just a few of them, but it's our mandate to prepare not a standard, but a technical guide that covers all the testing and all the criteria necessary to assess those innovative thermal insulation product to demonstrate compliance with the code. So I hope this was useful and practical for you. And if you have any questions, please let me know.
Thanks, Caroline. It was wonderful. Open for questions. Anybody wants to raise their hands or click and we can respond. Harry, looks like you're chewing at the bit there for questions. Oh, Harry, you have to unmute yourself.
Caroline, this is wonderful. I realize I'm thinking way outside the box. What we're thinking of, just to let you know, is using natural materials for insulation. And we hope to do an experiment. It's not done yet, at least here. It has to do with using straw coated with a light glazing of clay, and you throw it into a wall using Larson studs, 16-inch wide. You tap it lightly, take the forms away, and after it dries, you plaster it on the inside with clay, and on the outside, you use cedar shingles so that you have a breathable wall. So there's no vapor barrier at all. Anyway, I realize this is completely outside the box.
Yes, yeah. I'm always glad when people start to think about very natural type of fiber or very pro-environment type of products, which is great. And the only thing is where we have to be very concerned is a few things. The fire aspect, which is extremely important. As you know, as soon as there is a fire and there is death of people, it's a huge impact, has a huge impact, and can destroy a manufacturer with these great ideas. So it's so important that although it's natural fiber, it has to have a good performance under fire. The second thing I wanted to mention is the durability, because it may work well for the first year, but after subjected to cycles of weather, especially in Canada and in North, of cold, freezing, warm, water, wind pressure, and so on, is it going to be durable? Is it going to maintain its thermal resistance?
Caroline, that's really good points. The light straw clay we're talking about is what they used in Europe for years and years as the infill in timber frame structures. Well, some of those structures are still up and still operating 600 years later. So I'm hoping it's pretty durable.
Yes, unless there is some chemicals or components within the mix you're talking about, which are different from what they used in the past. So it may not be the exact same recipe. So it may not work exactly the same.
That's true.
And also, I don't know where in Europe they were using straw bales, but if you're using it up north in Canada, it's not the same condition necessarily.
Good points. You spoke about testing it, put it together and then test it. That's probably a pretty good way to operate. I think so many of the First Nations are trying to use natural materials for building. And so try our best to get as much insulation and fireproofing as we can. The problem probably is, well, we got to give it a try and, see how it works. I understand that light straw clay, because of the clay in it, actually doesn't burn.
Sorry, were you speaking? I think I lost you.
That's okay. There was a note in the chat room here that hemp is also a great alternative for straw in something like this.
Yes, that is true. It's another good natural product. And but again, we have to make sure that it's not a fire hazard, that it's, its performance is correct, that it's durable. So it has to perform. So it's great to have natural products, which I'm all for it. But as long as there is enough research and development in the product to make sure it's going to work properly for the conditions we have in Canada, and covering different aspects, durability of the thermal resistance, it's not going to increase or have a bad impact on growth of mold. There's so many things we need to look at.
You're exactly right. Catherine, can I switch completely to spray foam?
Sure, go ahead.
I'm really interested in spray foam, but how do you solve the thermal break where the studs are? I mean, it sounds like it works fine in the cavity, but then when you get to the stud, you've got a thermal bridge. How do you solve that?
It's the same situation for all the other insulation. It's not just for spray foam. Unless you have blocks and the foam is sprayed over the whole surface of the concrete blocks. You don't have a repetition of stud. If the insulation is installed on the exterior side, then you reduce that thermal bridge. And there are architects who specify assemblies such as wall without any insulation in the cavity. The whole insulation is on the exterior side.
I know that, And then it's continuous, isn't it? You don't have a thermal break.
Exactly, it's continuous and it keeps your structure warm and dry. So
that's true.
Any other questions? There are, if you turn
I want
your...
to say I love Caroline's accent. I could listen to you all day long.
Sorry, do you hear me?
Yes.
Okay, my name is Francois Denomé. Just to give you maybe the previous gentleman who who spoke just before me, there's a group in Quebec, Solution Era. They have a module where they have one person who present her own experience with the straw foundation. And they also present another module with hemp. In French, it's chanvre.
Exact.
Yeah, so they are dedicated to have the less tangible, I would say, impact on the environment. So that might interest you, or maybe we can share
Oh,
our
yeah.
profile.
That would, I'm very interested. I want to know all about it.
Yeah, Francois, if you want to send that to Claude or myself, and then we can share it with the group, because I think everybody would be interested.
Okay, perfect.
Okay, merci beaucoup. Thanks. Okay, any other questions? Richard, you're getting closer to the mic. You're thinking, I can see.
I think that the redundancy of trying to achieve something that has regional and climatic effects needs to be re-examined myself. So much activity happens in the central coast and the west coast and the north that not only thermal bridging is adamant on the walls, but on the roofs on all sides of the building. And I think here in Bellacula, we're now using building science, building technology, range screen applications, and application material selection, doing it different beyond the code. I think the underwriters laboratories of Canada need to re-examine the materials list for the regional areas. And it's common for me to say that because my experience where it's warm, vinyl siding's fine, but in the West Coast, it just creates more activity towards thermal bridging. It's all a compounded effect, even the type of asphalt shingles you use, but the type of insulation you use. Like blowing doesn't work in the West Coast because it blows up the backside of the building. So different applications, different ways to do things needs to be set as per regional areas.
Exact.
Claude here. I was just going to mention, Richard, I see something about passive home design and affordability for First Nations. And, it brings up to mind that with the, we'll call it the movement towards the National Energy Codes of Canada, basically getting a strong foothold across the country, it really means that from even the design build perspective, it's going to have an impact on everybody, and certainly I can see where it can have a huge impact on First Nation housing. Not that it's not going to have an impact on most all housing in Canada. So when I started looking at this, I started thinking, boy, we're going to have to see some major changes in thinking about the way homes are built, but even before they're built, how they're designed to do it properly.
Yeah, that's the step code, the new energy step code defines air tightness, air exchange. So here we're talking about looking at my perspective that there's so many variables that are cause and influence, whether it's negative or positive, upon a single family home. So some of the things that I'm doing here is like I have architects and sworn to me and say, we can't design a conditioned crawl space. I said, hold on here. I said, I'm a builder. Now we have one designed here in Bellacula that complements the habitable space. And we separate the 3 spaces for each one to have a function. Crawl space, I have a function as a heating spot. That's where I place my heating system. That's where I place my hot water tank. And it's sealed tight, and we have an interconnected heat pump that flows the air through the building and the space, so it's conditioned, insulated well. And we're finding that, you know, that application alone is defining a model that will meet the step code. In the habitable space, we're using rock salt insulation, an application like the young lady explained, that application is critical, that you have no voids, that you have perfect seal, air barriers, interior barriers, good windows, and proper sealed windows at the base, and proper sealed sill plates, top plates, and all the way to the roof line. Then we separated from the habitable space, the attic space, and the young man was talking about attic spaces. We found that with the metal roofing system, the one at 500 or one at 200 is not enough. There's so much thermal activity that the condensation builds up in there. And so we increased our attic spaces to 1 to 100 for that application. And for the asphalt, the fiberglass asphalt shingles also, we increased that. We had RDH building science people here in BC design the attic space, where we just wanted more positive outflow, but that's all pertinent to the application. For example, our first row of insulation follows the truss line right to the outside wall, right to the exterior. And the second row is perpendicular, and it's refitted to the outside, cut and groomed and fitted to the outside where it butts against the styrofoam insulation back coming from the outside wall. So, but like I said, you need to pay attention, and that's good factual information that we have on materials and products that are coming, but the application must be addressed, especially for regional areas. And when contractors come in and do what they do, there's nobody there to monitor them, nor is it affordable for a passive house design, like I said, putting 16 inches of insulation on the exterior wall. That's craziness, because it's not affordable for First Nations. It is what it is, but
Thank you,
we're doing
Richard.
something differently.
Wow, Richard, we should talk. We're trying to build 3 high efficiency houses at Roseau River. They're big. They're 6-bedroom, 2-bath houses. We're trying to build them for $300,000 a piece, but we have 16-inch walls packed with loose. It's cellulose, but it's driven. 24 inches of cellulose in the roof. This is on a sloped rafter deal, and 12 inches of insulation in the floor. We should keep in touch. I'll tell you how it works. Okay, we're still building.
Yeah, and that's all fine and fine. The people that live in that area know the area better than you or I, but we can provide them some insights, some tools to how we can do it better. And I find that a standard, if the first people in their communities, in their region, develop a building standard using selective materials that are most compatible or more compliant or not compliant, that complement the lifestyle and the elements, the climate makes a stronger and more durable product and an affordable. For example, here in Bella Coola, we found we're spending $12 to $13 a day to heat a home.
I have a question to your group. Does your group use prefabricated houses so far? Have you been using prefabricated houses?
In a nutshell, yes, but we've been challenged by prefabs. And so I will turn that over for communities that are using them. It's been a bit of mixed blessing from my understanding. Anybody wants to try to respond?
I think we're not using prefab, we're stick framing. We have a window of 6 months to build. And if the funding hits the right pocket at the right time, we can start, but otherwise it always becomes a challenge that you run into the winter months. But our thoughts are to create a building, not only a building standard, but building capacity, stimulate the economy, but look at the option of building inside and prefab modules. And just transfer the site, but the building science application with an energy file will be incorporated into the design as we go. So there's some thoughts about that now.
Any other comments, anybody? Okay.
Well, I think at least what we need to do is acknowledge Carolyn. That was a great presentation. I even learned a lot. I thought I knew a lot about insulation, but I certainly learned a lot more today, indicating what are some of the important things when we look at insulation, the types of insulation. Certainly we know there's all those codes out there, but as my students used to say, who really reads building codes? More importantly, it's not who's reading them. Do they actually build them and follow the building codes? So,
but I think what's interesting is, and I guess I raise as a question, so if somebody's putting out a tender, should the tender specifically state the type of insurance or type of insulation right to the code number that Carolyn's mentioned? Like I think it's important not to be vague, especially on insulation. And somehow, like I know on our technical northern guide, we don't go into that detail, if I believe, Claude, do we, on the guide? And maybe that might be an addendum we may want to do, is to include like this presentation as an addendum.
no, I haven't seen any reference to it. And your question raises a really, really good point, because I think we have a mixed bag. We have certainly architects and engineers, and not only do they do drawings, construction drawings, but usually specifications with them in which they would be, I would say, referencing or cross-referencing not only building codes, but certainly building standards, such as what Carolyn brought up. You know, the CAN and ULC standards, ASTM standards, etc. So yeah, I would say it's sort of a mixed bag of, it depends on who's in charge of the design, what's affordable. Is it a builder just building and kind of doing their own thing? Or is it something that is more customized to make sure that we are getting the right materials, right quality, and the right type of build?
You actually point out the right thing, because it's it has to be the right product for the project. You know, a good product can work well in a specific project due to its location, but that same good product may not be appropriate for another use, and especially in another location of Canada. So this, there is a specifier in the project, an architect or a specifier, they should specify which type of insulation and even the type and the class, because I've mentioned, depending on the type of insulation, the different standards refer to type 1, 2, 3, class 1, 2, 3, and grades as well. So they should even specify the type, because the different types has different level of properties. So it has to be specified. They don't need to specify the brand name, of course, but as long as you have that classification, then you pick the brand, the product brand name that has that specification.
And we talked about similar things in terms of windows and doors, like a door for Southern Ontario or a window may work well there, but if you don't put in your technical specifications for the northern climate, you're going to get that same window. So it's important to make that specification.
Like I said, regional, and Caroline said it itself, it does make a difference. And, you know, like John, I said, we need to develop as per region, a building standard, a building code for each region. You're the authority having jurisdiction, you should be designing something that complements your region, not the national ability. That's just a model, that's just the wheel, let's grease the wheel to fit our specific needs. I'll give you another insight that I realized on the west coast of BC, that being an inspector and builder, and I saw about 6,000 to 7,000 homes in BC, and my really compassion was the west coast. And it was common for me to walk on the west coast in their boiling water, preparing salmon. It was common for me to go in the interior and they're skinning moose and tanning a hide. And all the moisture that's retained, just like a wood wick that just flourishes through the home because of the staff effect. You know, those are the things, and those are the things that we have to address, because we build a home and it's costing us $300,000, like the young fella said. Is it really going to last? Not in the west coast. The life expectancy of a home in the west coast of BC is 7 years before we have to spend $60,000 to fix. That's craziness.
Yeah, and actually there is two things. The products used, they have to be installed at the proper location, but there's as well the design of the building. If the design is not well done, like soffit, if the design includes soffit cannot be 2 inches wide. You know, it has to be wider to fulfill its intent. The soffit has to, you know, ventilate, but as well it's protecting the facade to be exposed to the water. So the design is very important, and the selection of the products.
I think the biggest mistake First Nations First people have made was the belief of engineers and architects, and the product they delivered is all based on dollars. That was a good learning experience in my mind. How can we do it better? What's the challenge? Is the solution? And each has a solution. They just have to kind of put it together for themselves, and that's what I'm doing here. I'm just developing solutions. Yet we realize when my strengths or the strengths can become the weaknesses, a weak link. Too much air will freeze thaw rapidly. Too much heat will also cause a negative effect somewhere in the home. That's why I said it's critical to separate the crawl space from the living space from the attic space. Separate it. Treat it each as an individual aspect of a home. That's what we're doing here.
I think, Richard, what you're really talking about is an appreciation of true building science and getting a better understanding of how materials operate in a dynamic way in a particular region or area. You know,
It's true.
one size, one code does not fit all.
Nah, if you believe that, you're in the wrong planet.
Anyways, very interesting discussion. John, do you think we should wrap it up? It's a very, very good discussion we have going on. In fact,
Absolutely. Yeah,
it makes you think about maybe other opportunities here for webinars that can spin off of this.
well, there's a couple that I've been thinking of, but yes. Again, I want to thank Carol for taking the time to give this presentation. It's probably one of the highest numbers we've had. So people waited patiently, so appreciate that. And thank you, everyone. And our next one is next Thursday, and we restart the attic insulation, correct, Claude?
Yes, and I hope I have my compadre Harry joining us from a little bit further north than Windsor.
Okay. All right.
And maybe he's got a little more snow on the ground than I do.
All right. And finally, I did put a note on there to remind people that CCMC has a building officials help desk. And so if you have questions about installation and standards, they have a phone number and an email, and it's Carolyn and her colleagues who will respond to those questions. It takes a few days, but they need to know what these questions are so that it helps to inform them as well, especially in the northern climates and the remote areas of Canada. So if you have questions, please reach out to them. And I put that in the chat.
Again, thank you, everyone. And thank you, Carolyn.
You're welcome.
Thank you.